For this lesson, we are going to be writing exponential functions from a table. So let's see, what does an exponential function look like? It will be in the format of y is equal to a, which is going to be our initial amount. And when we're looking at a table, it will be our y-intercept. The growth factor, which is how much it's going to increase or decrease. And we find that with the table by dividing the second number in the table by the first number. And then we will end up finding some values when we multiply, when we take it to a power of x, which represents our time. So let's look at the first problem. Here's our table of x and y. We see that x does increase by ones. Okay, but remember, this is an exponential function, and it's not easy to see what is being multiplied, or for this one, divided, because it actually is going down. So in order to work this problem, I am going to write 150, the second number in the table, over the first number in the table. And when I put that in my calculator, I get 6/10. So now, in order to write our exponential function from this table, we are going to find where are we starting from? Where is our initial amount? So we end up with y is equal to, and it is always your y-intercept where x is 0, 250 times 0.6 taken to the x power. So that is merely just writing it. We are not solving it. We just came up with an exponential function from this table. But now the next two we're modeling real life. Let's check it out. You have a checking account that has a constant balance of $500. Let the function m represent the balance of your savings account after t years. The table shows the total balance of the accounts over time. So let's mark our text now, and then we'll see what they want us to find. Let's read letter A. Write a function b that represents the total balance after t years. So your checking account has a constant balance of $500. Guess what? That's extra information. This table tells us we're starting off at the very beginning at $2,500. And it says, let the function m represent the balance of your savings after t years. Okay, but down below for letter A, it says, write a function b, capital B, that represents the total balance over t years. So we are going to go ahead and we're going to write capital B is equal to, remember, you start off with what is that there? So it is 2,500. And we are going to multiply that by what is the answer to our division problem for this. So to start to solve this, I am going to write 2,540 over 2,500. When you do that division problem, you do get 1.016. And that, for this, is our growth factor because we see our balance keeps going up over the years. So we are going to write 1.016. And right now we're just putting an x there. Or not an x, actually, look, they said t, so I am going to write a t for my exponent. Just the letter t, because that's what they wanted there. So now we're going to find and interpret the balance in 8 years. So remember, when it's the balance in 8 years, this is going to be our t. So let's go ahead and let's write it again and work the problem. So our balance is equal to our initial 2,500 times our 1.016 to the 8 years. And I'm just going to separate this work because this was our brain coming up with that growth factor. Now, when you're putting this in your calculator, it's going to be very important that you know how to use it properly. So I want you to go ahead and put that in. And when you do, you should be getting 1.137 and so on. Remember, you do nothing to your calculator there. All you're going to go ahead and do now is you are going to multiply this number times 2,500. And when you do that, your balance in 8 years is going to be $2,844. And again, this is your balance after 8 years. Okay, not too bad. Let's try one more. So it says, modeling real life. The table shows the numbers Y of views an online video receives after being online for X days. Write a function that models the data. Predict the number of views the video receives after being online for 7 days. So let's mark this text. We know that Y stands for the number of videos. X is the number of days, and now they want us to predict 7 days. What might that showing be? So again, we need to start, and we're going to find where X is 0, and that's our Y-intercept, and that was a 12. So I'm going to write Y is equal to 12 times, and now I'm going to go ahead in order to find what I'm going to put for my growth factor. I'm going to over here do my little division problem. The second number in the table divided by the first number in the table. And when you go ahead and you do that division, you get 5.58. And that's how much its growth factor is, which is pretty significant. Well, notice it goes from a 12 to a 67 to 376. And look at that fourth day. Oh my gosh, 11,801. So this online video is really seeing a lot of views. Maybe it's Math with Marcia. I don't know. Well, let's look here. So now we need to put our 7 there for how many days? Remember, the first thing we're going to do is we're putting this in our calculator. And when we put that in the calculator, you're going to get something that looks like this. It's going to be 1691. And if you need to pause the video to make sure you can get that, please do. So once you have this in your calculator, don't clear it, just multiply it by 12. And that gives you your answer. So then Y is going to be equal to, you're not going to believe this, oh my gosh, 2,029,720 times, this was the views for the video, and that was just in, oh my gosh, 7 days. Okay, Math with Marcia fans, let's make it happen on my channel. Hopefully, all of these problems helped you understand writing exponential functions from a table. If this video was helpful to you today, please add a like, comment, and most importantly, subscribe for more Math with Marcia. See you again soon.